Let I am making two columns. First is whisper, second is helical. So that the differences can be understood. So first difference is teeth are parallel. Teeth are parallel to the axis of the shaft. The teeth are inclined to the axis of the shaft. Okay. So this can be understood. The board is visible.
Yes, sir.
It is visible up to here. यहाँ तक तो visible है ही. Let's see. यहीं तक visible है. And here it is visible up to. So let I am making the diagram of this per here first to understand the difference. Teeth are that this is the axis of the shaft. So teeth are parallel. So what is this distance? AB. This distance is face width of the gear. What is this distance? Let I say from here to here, CD. So AB is the face width and CD is the circular pitch, or you can say it is the pitch. It is the pitch. One point on one tooth to the corresponding point to the another tooth. So CD is the pitch. So this is somewhat terminology of the whisper here, and M is the module. M is the module. Now let me make the diagram for the helical gear. So in helical gear, that I make this diagram here to understand that this is helical gear. This is shaft again. This is the shaft. Now teeth are, this is the shaft axis. So here teeth are parallel to the shaft axis. This is the axis of the shaft. But now the teeth are inclined. So somewhat they are inclined this way. They are inclined this way, this way, this way, this way. So let's understand this teeth. I am extending. So this is the axis of the shaft. So teeth are making some angle with the shaft, and this angle is psi. This angle is psi. Psi is basically known as inclined angle, or you can say it is a helix angle. Okay. So this is the angle. Now what is this AB? This is the face width. This is the face width. And what is this CD? Anyone? So AB is face width, CD is again it's circular pitch, or you can say only pitch, right? Say circular pitch. CD is basically P. Here also CD is P, face width is B, but here the width or the length of the teeth, is equal to the face width. Length of the teeth, let I am saying L. L is equal to the face width because they are parallel. But in this case, the length of the teeth, and this is the length of the teeth, and it is not parallel to the face width. So you can say L will be somewhat given by B divided by cos psi. B divided by cos psi. How it happens? Because it will make a triangle over here. So this angle is basically psi, and this is the face width B. So in this triangle, and let the triangle name is element. Triangle name is element. So in this triangle element, I can write ML means L, and this is angle psi. So let me work with cos psi. So cos psi is based upon hypotenuse. So it is mn divided by ml. mn is equal to phase width, and ml is L. So L can be given at V by cos psi. I think it is now clear. Simple trigonometry. So teeth are inclined by angle psi. So if I extend this axis over here, so this angle is also psi. Now this angle is psi, this is also psi. They are vertically opposite angles. So this angle is also psi. And if I draw a perpendicular from C to this length of the teeth, so let I am drawing a perpendicular over here. So let this is the perpendicular. Let this point is some E point. So CE is perpendicular to length of the teeth, or let this is K point. So CE is perpendicular to DK. Now, so I can write CE is perpendicular to DK. So triangle CED is a right angle triangle. Triangle CED is a right angle triangle, and the angle DCE, this angle will also be psi by the simple geometry. Now, how this angle is psi? Because this angle is psi. The angle between this horizontal line and the teeth is direction, so it is psi. So angle perpendicular to these two lines will also be psi. So horizontal line perpendicular is this vertical line, and this is perpendicular to the direction of the teeth. So this angle will also be psi. ठीक है, किन्हीं भी दो लाइंस के बीच यदि एंगल साई है तो उनके परपेंडिकुलर्स के बीच भी एंगल साई ही होगा. So that's why this DCE will also be psi. DCE will also be equal to psi. ठीक है, this is psi, this is vertically opposite, and this is perpendicular. That's why this angle will also be psi. Now, in this triangle, CD is the circular pitch, and this is the perpendicular direction of the tooth. That's why it is known as perpendicular pitch, or you can say it is the normal pitch. So CE is known as normal pitch. So let me write it here. So CE is basically, you can say it is a perpendicular pitch or it is a normal pitch. So it is, I am representing this by MN. So it is a, not MN, it is PN, it is pitch. That's why it is normal pitch. MN means normal module, but this is normal pitch. So CD is the circular pitch, CE is the normal pitch. Now this is a right angle triangle. By simple trigonometry, I can write, but I can write cos psi equal to, in this triangle, I am working in CED triangle. So cos psi is based upon hypotenuse. So base is CE, hypotenuse is CD. So it is Pn divided by P. So from here I have Pn equal to V cos psi. Pn equal to V cos psi. We are just discussing what are the differences because of this angle. By inclination of this angle, what will be the differences? So one difference is there are basically two directions. One is normal to the teeth, and one is transverse. One is the transverse direction. But in spur gear, normal direction and transverse direction both are same. So basically, you can say in case of spur gear, this psi is 0. Psi equal to 0 in case of.
सर दिखाई नहीं दे रहा ऊपर.
Psi is 0.
सर ऊपर दिखाई नहीं दे रहा सर.
Okay. So I will write it here. For spur gear, I can say psi equal to 0. Okay. So spur gear is a helical gear whose helix angle is 0. एक definition ये भी हो सकती है spur gear की, है ना? So spur gear is a type of helical gear whose helix angle is 0. So if the helix angle is 0, the teeth will be parallel to the axis, then it will be a spur gear. Naturally. So in the case of spur gear, the normal direction and the transverse direction both are same. But in case of helical gear, there are two directions. One is transverse direction and one is the normal direction. So because the force acting on the spur gear is perpendicular to the direction, that's why this direction is much important. So perpendicular direction is much important. That's why some two terms will be there, like normal circular, normal pitch, and the normal module, the normal pressure angle, and everything will be twice. So Pn equal to P cos psi. So I think this derivation is clear to you. Now I am drawing a perpendicular over here. That I am making a perpendicular over here. I am drawing a perpendicular from here. From C to perpendicular on, or I am making this horizontal, I am drawing horizontal line from here which cuts it at point F. So CFD is a right angle triangle again. So this CF is known as axial pitch. CF is known as axial pitch. So CF is axial. So by again the trigonometry CFD, the angle C is 90 degree. Angle C is 90 degree. It is right angle triangle. So what is angle F? Anyone? What is angle F? So angle F is again psi. It will be equal to psi. Why it is psi? Because this angle and this angle are alternate pair. They are alternate pair. And if you extend this, then this is psi, then they are vertically equidistant. So psi and psi. This is psi, so that's why this is also psi. So this is also a right angle triangle in which one angle is psi. So in this angle, PA is the axial pitch and CD is the circular pitch. So for this angle, this is the perpendicular, this is the base. So perpendicular upon base is basically tan psi. So I am applying in this triangle CFD. So triangle CFD, I am applying tangent of psi is perpendicular upon base. So perpendicular is CD, base is CF. So it is CD divided by CF. So it is P divided by PA. It is circular pitch and it is the axial pitch. So from here, this PA will be given by P divided by tangent of psi. जितने भी फॉर्मूले मैं बना रहा हूं बोर्ड पर बाय हेल्प ऑफ ट्रिग्नोमेट्री है ना, ये सब आपको मेमोराइज हो जाने चाहिए है ना, बिकॉज these formulas will help us in solving the numerical questions, है ना. And again the concept, you know, what is circular pitch, what is normal pitch, and what is the relationship between them, how the triangles are formed, how trigonometry is applied. So I think we have applied trigonometry in three triangles. First triangle is this one, element, है. So we have calculated the length of the teeth. Basically, it is the b by cos psi. Or you can say in the transverse direction the phase width is b, but in normal direction the phase width is b by cos psi. ठीक है, जो length है वही phase width है normal direction में. So normal in the tangential direction the phase width is b, but in normal direction the phase width is b divided by cos psi. And cos psi is always less than 1, and less than equal to 1. That's why this phase width is higher than this phase width. Now, this inclined phase width is higher than this phase width. Okay, so in the normal direction, the phase width will be higher. Now, one triangle element by which we have found the relationship between phase width, one direction CED, one triangle CED by which we have found the relationship Pn equal to P cos psi, and one triangle CFD by which we have found the relationship between P and K. Okay, three formulas. So I think it is clear. अब यहाँ तक clear है, so that I can proceed.
Yes, sir.
So I am rubbing it. Please take a screenshot if you want.
सर इधर से कर दीजिए, उधर से मत कीजिए.
If you want, just take a screenshot. So can I rub it?
Yes, sir.
Now, we have proved Pn equal to P cos phi. Pn can be written as module multiplied by number of teeth. हमें क्लास में हाँ क्लास में थोड़ी देर में So Pn is P cos psi. Similar relationship can be developed Mn equal to M cos psi. Mn equal to M cos psi because Pn can be written as pi times module. P is pi m basically. P is what? P is pi m. So Pn can be written as pi times Mn, and this P can be written as pi times M. That is cos of psi pi by m. So Mn equal to M cos. Okay. So Mn equal to M cos psi. Right. Now similarly, tangent of alpha n is tangent of alpha cos of psi. So alpha n is the pressure angle in the normal direction and alpha is the pressure angle in the transverse direction or in the tangential direction. So alpha n. Now come to the force analysis. So in case of spur gear, there are only two forces. In case of spur gear, the force is coming like this. This is the P. This P is acting at some pressure angle alpha. So P is having only two components. One is tangential force and one is compressive force or radial force. So in case of spur gear, ये जो मैंने डायग्राम बनाया है और spur gear force analysis, P is acting some pressure angle. It is having two components. One is tangential component PT, which is responsible for the bending of the teeth, bending phenomena of the teeth, and this is responsible for compressive phenomena of the teeth. So due to bending, this force is responsible. So P is having only two components in case of spur gear. So this is the force analysis of spur gear that we have already learned. Now I am coming to the force analysis of helical gear. So the topic is force analysis of helical gear. So in case of helical gear, teeth is inclined. Teeth is inclined. So this is the teeth. This is inclined. So it is making some angle alpha n. It is making some angle alpha n. Here is the angle alpha, but here the angle is alpha n. So I am giving this angle as that alpha n. This angle is alpha n. So this is P. So by the law of parallelogram, this P has two components. So this P has two components. One is P cos of alpha n and one P sin of alpha n. P cos alpha n is the normal pressure angle, P sin alpha n, P cos alpha. These are the two components. Okay. Now, this component is P cos alpha n and the perpendicular component is P sin alpha n. So this is basically responsible for the compression phenomena. So this is PR. As in case of spur gear, so this is PR. Now this P cos alpha n is normal to the tooth. It is normal to the tooth, but tooth is inclined by an angle psi. So that I am drawing a horizontal line over here. So this angle is psi. This angle is psi. So because of this angle, this force is having again two components. This force P cos alpha n is having two components. First component is with cos psi and second component is sin psi. So this is having again two components. No, I have written wrongly. This is PR, P sin alpha n, and P cos alpha n is having two components. P cos alpha n cos of psi and P cos alpha n sin of psi. एक बार फिर से देखिए. The resultant force is P. It is having two components due to this angle alpha n. So P cos alpha n and P sin alpha n. And this P cos alpha n is again having two components because of this angle psi. So P cos alpha n cos psi and P cos alpha n sin psi. So this is the PT, which is equal to P cos alpha n cos of psi. So this is basically PT, it is the tangential force, and this is the important force. This force is responsible for the bending failure of the helical teeth. Okay? In case of spur gear, P cos alpha is responsible for bending of the failure teeth, but in case of helical, P cos alpha and cos psi. This is the PT, and this will be come into picture in the calculation and the numericals. We have to find this one, PT. So PT is dependent on pressure angle also. PT is dependent on the angle, inclined angle of the teeth also. Okay. So P cos alpha and cos psi is the tangential component, and P cos alpha and sin psi is the axial component. It is the axial component. So there are three forces: PT, PA, and PR. So it is a 3D type of structure. And in case of spur gear, only two forces, two components. But in case of helical gears, there are three components. So force analysis of helical gear includes 3 dimension of the forces. It includes 2-dimensional forces in a plane. Okay. So let me give, this is equation number 1, this is equation number 2, and this is equation number 3. So there are 3 equations. So first equation tangential force, second equation axial force, third equation radial force. Yeah. And P is the resultant of all these forces. So P vector is the resultant of PR plus PA plus PT. Yeah. It is the vector summation of all these 3 forces. Here P is the summation of PR plus PT dot A. So in case of spur gear, it has only 2 components. In case of helical gear, it has 3 components. So I have 3 equations here. If I divide equation 3 divided by 1 or 2 divided by 1, I will find some relationship. I want to eliminate this P. I want to eliminate this P because this P is unknown. This P is unknown because we are knowing only the power and the RPM in the numerical questions. Power and RPM. With the power and RPM, we are unable to find this P. So we want to eliminate this P. So how can we eliminate this P? So if I divide equation 2 divided by equation 1, then I have PA divided by PT. PA divided by PT is P cos alpha and P cos alpha will cancel out. Only the relationship is sin psi and cos psi. So it is sin psi divided by cos psi. Sin psi divided by cos psi, or you can say it is tan psi. So from here, PA equal to PT tangent of psi. PA is PT tangent of psi. So this is the important equation. And sometimes you have to find axial force. In the gate exams, it is required to find the axial force. And if you are knowing the PT by some method, you can find PA. But only you have to know the helix angle. Now, if I divide equation 3 divided by equation 1, equation 3 divided by equation 1, so I have PR divided by PT equal to P sin alpha n divided by P cos alpha n cos of psi. PP cancel out, sin upon cos is tangent of alpha n. So it is tangent of alpha n divided by cos of psi. So from here you have PR equal to, from here PR equal to PT tangent of psi n, PT tangent of psi n divided by cos of tangent of alpha n, not psi n, tangent of alpha n, sin alpha n, cos alpha n. So it is tangent of alpha n divided by cos of psi. So this equation is also important. If we know the PT, how can we find PT? PT can be found by 2 times torque divided by pinion diameter or the gear diameter. We can find PT from here, and we can find MT from the relationship of power and RPM. So MT is given by, you already know, 60 10 to the power 6 kilowatt divided by 2 pi n. So we will first calculate torque, then calculate PT, then calculate axial force, then calculate radial force. In this situation, we does not need the resultant force. We does not require the resultant force. So this is the force analysis of the helical gear. So I think it is clear. Force analysis. 3 components. In spur gear, only 2 components are there. In helical gear, there are 3 components. Give me 1 minute or more. I want to find the center distance. आप इसको नोट करना. Please take a screenshot of this. हाँ जी, मेरी आवाज आ रही है?
सर वो जो
So today we have discussed the terminology of the helical gear and the force analysis of helical gear. Now I will show you the center distance. Center distance. Center distance is given by n half of v1 plus v2. The basic formula in case of spur gear we have done. So this can be written as v1 can be written as m times z1, v2 can be written as m times z2. M times z2. So it is m by 2 z1 plus z2. This is the center distance. Same formula in case of spur gear, but it can be extended. We have the relationship n equal to n cos psi. From here, m equal to mn divided by cos of psi. So in place of m, I am writing mn divided by 2 cos psi z1 plus z2. This is the center distance between the helical gears. Very simple. Just use the relationship of, because in numericals normal module is calculated, so normal module is available. So that's why formula has been developed in the form of normal module. And the relationship is m equal to n by cos of psi. So I think this formula is clear to you.
Yes, sir.
Okay.
Yes, sir.
So अब देखिए last topic for today. So I was discussing the differences. So in case of spur gear, in case of helical gear. So देखिए, what are the differences? Teeth are parallel. Teeth are parallel. Here the teeth are inclined. First difference. Teeth are parallel to the axis of the shaft. Teeth are inclined. Teeth may be inclined in this fashion also. Teeth may be inclined from left to right, and teeth can be inclined to right to left. Or bottom to top, or top to bottom. The direction of the teeth. So in this case, this angle is psi, and in this case, this angle is psi. Helical, the logic will be same. So if teeth are inclined from bottom to top, teeth are inclined from bottom to top, then this is known as left hand helical teeth. This type of helical is known as left hand helical teeth. Left hand. And this type of teeth is known as right hand helical teeth. There are 2 directions. One is left, one is right. So when we go for meshing, so this is the gear, this is the pinion. Bottom is pinion, this is the gear. So if the gear is having left hand teeth, then pinion must have the right hand teeth. Only when the meshing is possible. Okay. So meshing of the helical gears, if the pinion is having right hand teeth, then gear must have the left hand teeth, or the vice versa. So I can say if psi is plus 30 degree for one gear, then psi will be minus 30 degree for the another gear. Okay. So their magnitude must be same, their helix angle must be same, but their end of helix must be different. So left and right here known as hand of helix. So for the proper massing, hand of the helix must be different for the pinion and gear, but angle of helix, and this psi is known as angle of helix. And angle of helix must be same. मतलब ऐसा नहीं हो सकता कि psi की वैल्यू pinion के लिए तो 45 डिग्री है और helix के लिए psi की वैल्यू 46 डिग्री है. No, it is 45 degree, it is 46 degree. There is a difference in the helical. So the massing of the teeth will not be possible. So there will be no power transmission. So this is very important. The angle of helix must be same for the pinion and gear, and hand of helix will be opposite. And one more thing. The helical gear can be classified in two parts. Helical gear can be classified in two parts. One is
सर इसको कल करा देना सर.
बस understanding. So one is parallel helical gear and one is crossed helical gear. So in this case, axes are parallel. In this case, axes are not parallel. So I think this is sufficient for today. In the next class, we will solve. We will do some derivation between the relationship of virtual number of teeth, and after that we will go for the numerical. है ना, थोड़ा सा पढ़ के आइएगा helical gear को, right? So just fundamental we have discussed today about the helical gear. So can I end the class?